Hello, I'm Ruan Rajapaksha. Today I'm planning to discuss Einstein's E equals mc squared paper written in 1905 fully from start to end. I will go through word by word and explain in simple English so that anyone can understand. So then Einstein wrote two papers on this subject. The first one was the paper on special theory of relativity, and then this paper that I'm going to discuss, E equals mc squared paper. And there were a couple of other papers on Brownian motion and various other things, but these two are the big ones, and the Brownian motion is the one that he got the Nobel Prize. So without further ado, let's start. So the name of the paper is Does the Inertia of a Body Depend Upon Its Energy Content? By Albert Einstein, 1905. So what is he saying here? The inertia, we know there are inertial mass and the gravitational mass. So he's referring to the inertial mass. So inertial mass is it depending upon its energy content? That means, is the inertial mass going to change if you lose energy? That's the question he's asking. But today we know that if you lose energy and mass is different sides of the same coin. Today we know that, but before that we did not know that. Energy is one thing, mass is another. We didn't know that energy can be converted to mass or vice versa. Today we convert that all the time in particle accelerators, and in nuclear bomb is one of the good examples. So the results of an electromagnetic investigation published by me, that he's referring to his special theory of relativity, recently in this journal lead to a very interesting conclusion which shall be derived here. So he's saying special theory is going to lead to a very interesting conclusion. What is that interesting conclusion? It's none other than E equals mc squared, or energy can be converted to mass or vice versa. That's what he's talking about. There I based upon myself the Maxwell-Hertz equations for empty space along with Maxwell's expression for the electromagnetic energy of space, and also on the following principle. Here he is talking about the special theory of relativity, that he used Maxwell equations, the constancy of light. We don't really need that for this paper. So let's continue. The laws governing the changes of state of physical systems do not depend on which one of two coordinate systems moving in uniform parallel translation relative to each other. These changes of state are referred to principle of relativity. Again, he's referring to his special theory of relativity. The laws are not going to change just because you move. A person is traveling in a train. The laws of physics not going to change just because he's traveling in a train. That's what he's saying here. All the inertial frames have the same laws of physics. Based on these fundamental principles, I derived the following result, among others. Let a system of plane, now is where the paper is going to start. This is where this particular paper is going to start. This is basically the preamble. He's referring to his previous paper because he used this equation from the previous paper. This comes from special theory of relativity. So let a system of plane waves of light referred to the coordinate system x, y, z possess the energy L. Let the direction of the ray, the wave normal, form the angle phi with the x-axis of the system. If we introduce a new coordinate system, epsilon, eta, zeta, which is uniformly parallel translated with respect to the system x, y, z, and whose origin is moving along the x-axis with velocity v, then the above mentioned quantity of light measured in the system epsilon, eta, zeta possesses the energy. L star is the energy of the epsilon, eta, zeta system measured from that system, L is the energy measured from XY Z system. And simple V is the velocity of epsilon eta theta system relative to the XYZ system. And cos phi is the angle that the radiation makes with x-axis. Again, this constant, it comes known as gamma. That's the special relativity constant that came from the previous paper. So I have a little diagram here to explain everything what he's saying. So okay, this is what he's saying. So let us consider x, y, z coordinates, and there's a radiation moving in this direction and that direction. He says in the next sentence it goes in both directions. And then this is the epsilon eta theta system, and that is moving with constant velocity v relative to O. O dash is moving along x-axis with relative velocity lowercase v. So that's what he's saying so far. And L equals energy of the ray in the XYZ system. L is the energy of the ray in the XYZ system. L star is the energy of the radiation seen from epsilon eta theta system. Now if this person measure this energy, it would be L star. Now why it is different? That is theory of special relativity. And it gives, these equations come from theory of special relativity. Now Einstein uses uppercase v for the speed of light. Today we normally use, lowercase c. So it would be, this v is the velocity between the two frames, epsilon eta theta frame and xyz frame. Cos phi is the angle that the radiation makes with the x-axis. L is the radiation, energy of the radiation measured in the XYZ axis. L star is the radiation measured in epsilon eta theta system. So this is the equation. This equation base, it should be L star should be equal to L if we didn't have the special relativity, right? I mean, in the past, before special relativity, it would be the same. Energy of a radiation is not going to change just because it moves, but the special relativity says that it will change. Okay, so far I think it should be very easy. So let's go back to the paper. So we came up to this equation. L star should have been equal to L if the two systems are not moving, but they're moving, then we have to have the relativity correction, where uppercase v denotes the velocity of light. Normally today we use c, but he used uppercase v. We may make use this result in the following. Let there be a body at rest in the system XYZ whose energy refers to the system XYZ is E sub 0. The energy of the body with respect to the system epsilon eta theta, which is moving with velocity v as above, shall be h sub 0. I'm going to explain this with the diagram. So let's read on. Let this body simultaneously emit plane waves of light of energy L by 2 measured relative to XYZ system in a direction forming an angle phi with the x-axis and equal amount of light in the opposite direction. So L by 2 goes in one direction, the L by 2 goes in the other direction. All the while the body shall stay at rest with respect to the system XYZ system. This process must satisfy the energy principle, and this must be true according to the principle of relativity with respect to both coordinate systems. If E1 and H1 denote the energy of the body after the emission of light as measured relative to the system XYZ and epsilon eta theta respectively, we obtain using the relation indicated above E0 equals E1 plus L by 2 plus L by 2. Don't worry, I'm going to explain everything. I'm just going to read it first. So relax. If you don't understand, Don't get upset, because I'm going to explain with my diagrams, so it will be easy to understand. So let's I'm just going to read these equations first, and then in my diagrams, when you see the diagrams, you would understand easily. H0 equals H1 plus this equation plus H1. It boils down to this. All right, so subtracting H0 minus E0, subtract this from the subtract this from this, and then you would get this equation. Let's go to my diagrams. Okay, we have the XYZ system, and there's a body, and that body has an energy of E0. So far so good. And epsilon eta theta system is moving with velocity v. So this body is moving with velocity v on this way, and this has an energy of h sub 0. Now I want to give something. I'll have this here. Let's say there's a train. There's a train and there's a person A in this train. What is the kinetic energy of the train relative to person A? 0. Because the train is not moving relative to person A, because he's inside the train. He's not going to hit by the train, because there's no kinetic energy in his frame. His frame is same as the train's frame. They go together. So there is no kinetic energy. He's not going to get hit by the train and die. But there's a person in the tracks or in the station, person B. So when the train is moving, with relative to him, there's a kinetic energy in the train. That fact, keep that in mind. According to this person's frame system, this is epsilon eta theta frame. Train has a kinetic energy. So energy according to XYZ plane, the person A, the energy of the train is whatever the internal energy of this train, chemical, fuel, whatever. There is no kinetic energy relative to A. But relative to B, there is the internal energy of the train stays the same, but on top of that, there is the kinetic energy of the train. Remember that fact. Okay, let's go back to my diagram again. Okay, so here we have a body. So E0, H0 measured from the epsilon eta theta system. There is kinetic energy in the body in relative to epsilon eta theta system. Now let us define E1 and H1. E1 equals energy of the body after emitting the radiation with respect to XYZ system. Okay, after now this is E0 when the radiation is emitted. Einstein is saying that the energy is going to reduce here. Energy is mass as per Einstein. So the mass is going to reduce. That's what he says. We'll see. So the E1 has to be smaller than E sub 0. Similarly, H1 is the energy of the body after emitting radiation with respect to epsilon eta theta system. So E0 and E1 are relative to XYZ system. Now why L by 2 and L by 2? Because he says that if you go here, radiation goes in both directions. See, I marked it that. He's saying in the direction forming an angle phi with the x-axis and equal amount of light in the opposite direction. So L by 2 goes in one direction and L by 2 goes in the other direction. That's what it is. So let's stay here. E0 is the energy of the body relative to XYZ system. E1 is the energy of the body after the radiation. So E1 has to be less than E0 because it has emitted some radiation. So E1 plus this amount is what to get to the initial state. It's like you had some money and then you spend some money, let's say you had $100. Now you have only 90, you spend 10. So 90 plus 10 equals 100. That's what it means. So the energy after radiation plus the energy that was sent out through radiation, and that should equal to E0. Okay. Same thing with here. H sub 0 is equal to H sub 1. Now we are H numbers, letters are representing the epsilon eta zeta system. So H sub 0 is equal to H1 is after the radiation plus L by 2 is the relativistic term because it's moving with velocity v. Epsilon eta zeta system is moving with velocity v. So we get this L by 2 times this relativistic term. And this can be simplified to this one here. Capital V, uppercase V is the speed of light. Today we say c. So this can be, so L by 2 plus become L. V over V is very small. Uppercase V is the speed of light, so we can ignore that. So L by 2 plus L by 2 become L, and this denominator would stay the same. Okay. So he ignores this term because uppercase V is the speed of light and it's a very big number. For small speeds, this number becomes 0, almost 0. This becomes almost 0. So L by 2 plus L by 2 becomes L. Now we can subtract one from the other. H0 minus E0 equals H1 minus E1. He brought the H1 minus E1 term to this side, and you get this term up here. H0 minus E0, H1 minus E1, and this one, and L by 2 plus L by 2 is L, and minus L is here. Okay, it's simple arithmetic or algebra. So we have a term here. What is H sub 0 minus E sub 0? H sub 0 is the initial energy measured in respect to the epsilon eta zeta system. E sub 0 is the initial energy before the radiation measured using the X, Y, Z system. Same thing. This is H1 and E1 after the radiation is emitted. So the difference, and this term should be what we lost from the radiation. So the now let's read it. The two differences of the form H minus E occurring in this expression have a simple physical meaning. H and E are the energy values of the same body, referred to two coordinate system in relative motion. The body being at rest in one system, XYZ system, the body is rest. Hence it is clear that the difference H minus E can differ from the body's kinetic energy K with respect to the other system, epsilon eta zeta, solely by an additive constant C, which depends on the choice of the arbitrary additive constant of energies H and E. We can therefore put H0 minus E0 equals K0 plus C. The C is, he just put in an additive constant because remember at that time they still had this absolute ether idea, and Einstein probably unconsciously had this, that there is, it's like the mean sea level, I mean, we are looking, let's say, the difference between Mount Kilimanjaro, let's say Mount Kilimanjaro is, let's say, 20,000 feet. Mount Everest is 25,000 feet. We could just say But where did we, the difference between mean sea level and Mount Kilimanjaro is 20,000. But the mean sea level is 0, but it could, we just made it 0, but it could be, somebody else could say, well, we are going to take the center of the earth as 0. That's the absolute 0, not the mean sea level. So we have to add the mean sea level to the center of the earth distance, and that has to be added to the both situations. So it's like we have the absolute energy stratum, and then we have to add that to both equations. So anyway, if you don't understand that, just ignore it. It's just that it has no meaning. It has no meaning. It just it's the people at that time still had this notion of, even though Einstein totally got rid of the absolute space, absolute energy stratum, vacuum energy, whatever. Well, I don't know whether he knew about the vacuum energy. I'm digressing now, but it's not been explained. It just cancels out. It's a meaningless constant, has no meaning. But it's just that, in my opinion, he's thinking some kind of absolute data frame that he has unconsciously in his mind. That's how I look at it, but it has no meaning. As I said, C does not change during emission of light. It's like, the distance between the center of Earth to mean sea level is not going to change, if you go from Kilimanjaro to Mount Everest. It's something like that. So we get K0 minus K1. K is the kinetic energy. K0 is the kinetic energy, which I explained that if something is moving, or the train is moving, the person on the street will see a kinetic energy in the train, but person inside the train don't see that kinetic energy. That's what it is. So this equation should be clear. This is H sub 0 is the energy measured using epsilon eta zeta system. E0 is the energy as per XYZ system. K0 is the difference, is the kinetic energy. Ignore this. This has no meaning. K sub 0 is it's like person. H sub 0 is like the person on the street, and the person inside the train is E sub 0, the energy for him. The difference in energy between person in the street and the person inside the train is the kinetic energy. Correct? Now, after emitting the radiation, you get H1 minus E1, kinetic energy K1, same thing. Since C does not change during the emission of light, thus we get, you just reduce one from the other, K0 minus K1, the C cancels out. Now, we get H0 minus E0 minus H1 minus E1. We derive that equation. H0 minus E0 minus H1 minus E1 L. This is this term here. Good. So that term comes in. Now he goes on. The kinetic energy of the body with respect to epsilon eta zeta decreases as a result of the emission of light by an amount that is independent of the body's characteristic. So due to radiation, the kinetic energy of the body with respect to decrease, I would say it should be not kinetic energy, it should be the total energy, kinetic energy plus the energy due to mass. Furthermore, the difference K sub 0 minus K1 depends on the velocity, exactly like the kinetic energy of the electron. I have no idea what that means. Neglecting quantities of the fourth and higher orders, we can put. Where do you get fourth and higher orders? Let's look at that. So let's go back. Remember this equation. K sub 0 minus K1 L times the gamma term here minus 1, right? So let's see how we get fourth and So we came this initial energy, we did all that. We are coming to, I talked about the train issue. We did talk about that, this term here, k sub 0 minus k1 L times the relativistic term minus 1. So let us multiply top and bottom with square root of 1 minus v squared over c squared. So that goes up there, and 1 minus v squared over c squared comes here. Now square root of 1 minus v squared over c squared is 1 minus v squared over c squared to the power half. And this Taylor expansion, I think, is 1 minus 2x to the power half is equal to 1 minus x minus half x squared minus half x cubed, etc. So 2x, let's call 2x equals v squared over c squared. Okay, let's say 2x is equal to v squared over c squared. So then x is equal to v squared over c squared divided by 2. Okay, so far so good. So 1 minus 2x is 1 minus v squared over c squared. 2x is equal to v squared over c squared to the power half. 1 minus x is v squared over 2c squared minus half x squared, v to the power 4 divided by 4c to the power 4. Oh, it should be v to the power 4. My mistake. V to the power 4, 4c to the power 4. As he said, higher order terms ignore. 4c to the power 4 is a very big number, so we can ignore. It should be v to the power 4 divided by 4c to the power 4. So what do we end up? So k sub 0 minus k1 is L. We are going to ignore this. 1 minus v squared over 2c squared. Go here. 1 minus v squared over 2c squared. This term still remain 1 minus v squared over c squared and minus 1. So basically in this term we are going to replace with 1 minus v squared over 2c squared. So 1 minus v squared over 2c squared minus 1, we take this one to the up, minus 1, minus minus plus v squared over c squared. So k0 minus k1 is equal to L times v squared over 2c squared. 1 minus 1 cancels out, 1 minus 1, minus v squared over 2c squared plus v squared over c squared becomes v squared over 2c squared. Okay, and this term still remain. And v squared over c squared is a very small number. C is a very high number, so that we can ignore. So this is how Einstein got k sub 0 minus k1 Lv squared over 2c squared. This is how he got. Now m is the change in kinetic energy that he the difference between the kinetic energy of the system. And that's the energy that was released, and that should be equal to the mass. Energy is mass. If body emit radiation L, it mass reduces proportionate to kinetic energy. Actually, it should be in the both systems, the internal energy is the same. So internal energy doesn't change, assuming that there's a change in the mass. Internal energy, separate amount other than the change in mass due to radiation. So the mass reduction is m. L is the energy emitted. Lv squared over 2 is E. If we define this as E energy, and then E equals mc squared. M Lv squared c squared. Here c is the not the additive constant. Here I just put uppercase V. I just replace with uppercase V. I replace with c, the speed of light. So that's how we get the E equals mc squared equation. So let's finish the Einstein's paper now. So we came here, we did this, and okay, this one I showed you with the tail expansion or the binomial expansion, whatever. So you could get that way. And then he goes on to say, from this equation it follows directly, if a body releases the energy L in the form of radiation, its mass decreases by L over V squared. Since obviously here it is essential that the energy withdrawn from the body happens to turn into energy of radiation rather than into some other kind of energy, we are led to the more general conclusion. The mass of a body is a measure of its energy content. The mass is energy. If the energy changes by L, this is the change in energy, the mass changes in the same sense by L over this amount, I think 9, if the energy is measured in erg and mass in grams. So there's a constant in here. I don't know what that is. Perhaps it will prove possible to test this theory using bodies whose energy content is variable to a high degree, sols of radium. If the theory agrees with the facts, then radiation transmits inertia between emitting and absorbing bodies. It should be radiation transmit mass, inertial mass, between emitting and absorbing bodies. So, thank you very much for listening, and I hope you understood everything. If there are any comments, please put under comments. Thanks a lot.